This video covers growth and decay of exponential functions. So our exponential functions have the general form y equals a times b to the x, where the a value cannot equal 0, the b value must be greater than 0, and the b value cannot equal 1. So the a and b are representative of numbers, whereas the x is an independent variable, meaning we're always going to see the x written as x in the function. And then the domain of these, if we look at these two graphs down here, there's arrows at the end, meaning it continues forever in either direction. So if we look at the domain, meaning the x values, they're always going to reach all the way to the leftmost side, so negative infinity, and they're always going to reach all the way to the right side of the graph and beyond. So our domain is always negative infinity to positive infinity. So these exponential functions are categorized as either growth or decay. So over here, we'll see this as an example of growth, because as we move from the left to the right of the graph, this is an increasing graph. So the increasing shows us that it's growth. All of these examples of these equations are also growth. To determine it, we look at the b value, which is the value, you could also think of it as b being the base of the exponent. So the b value here, 4/3, is greater than 1. This b value is 5. 5 is greater than 1. This one, 1.65, is greater than 1. So if the b is greater than 1, then it means it is a growth function. On the other hand, some of these exponential functions are decay functions. So if we look at this graph, as we move from left to right across the graph, this is decreasing. So this decreasing graph shows us that it is exponential decay. Again, we look at the b values. This time we notice this b is 1/4, which is less than 1. This b value is 2/7, which is also less than 1. This b value is 0.75, which is less than 1. So if b is less than 1, then it means it is a decay function. One thing we want to be careful about is negative exponents. So you might see an exponential function, let's say it looks like this maybe. Well, we have a negative exponent right there, so we need to remember our exponent properties. What that does is bump that term to the opposite side of the fraction. So we can rewrite this as y, I'll write it over here, y equals 2 times 1/3 to the x. So what that negative does is move the 3 to the denominator, and now the exponent is positive. So at first, when you look at this, you might think, oh, well, b is 3. 3 is greater than 1, so is it growth? But no, you need to be careful of what this negative exponent is doing. You need to rewrite it. Now we notice that b is 1/3, which is less than 1, so this would actually be decay. Many students would say that it's growth without taking that extra step to check the negative exponent. So just be careful of that trick.